And these are integrated to 4.2.3 notes. We're now going to talk about the idea of using sine, cosine, or tangent, depending on the ratio that's given to us, to be able to find the angle. So we're going to be talking about is the inverse operation. Just like anything else, if you are adding two things together and you want to undo the addition, then you would subtract. If you have two things being multiplied together and you want to undo the multiplication, you're going to divide. We have inverse operations for most operations. So the one that we are going to focus on is being able to get rid of sine, cosine, or tangent, so to undo that. Well, the inverse operations are going to be specifically sine inverse, doesn't have a fancy name, it's just sine inverse, cosine inverse, or tangent inverse. So what we're going to do is we want to make sure that we can identify what the ratio is based off of the picture. So if we take a look at this picture and the example that's given to us, we know the sides that we have would be the hypotenuse, and we would know opposite, the theta is going to be our opposite side. And then right next door to it is going to be the adjacent side. Notice we don't have any numeric value or anything on the opposite side. So we're actually just going to ignore that. So think about the ratio that we have. Well, with adjacent and hypotenuse, we know that this is going to be the cosine ratio. So if you take a look, we know that cosine of the angle is going to be the adjacent side over the hypotenuse, so 10 over 13. It's at this point, though, where we need to get rid of cosine itself, because what we're trying to solve for specifically is just the theta. So if you look, we have that cosine in front of this that needs to go. So the inverse operation of cosine is inverse cosine, and we would apply that operation to the entire equation. So really what's happening here is that we would do cosine inverse of each side of the equation. By applying it to just the left-hand side, we would get cosine inverse of cosine of theta is equal to, and again applying it to both sides, cosine inverse of 10 over 13. On the left-hand side, we know that cosine inverse, or inverse cosine, and cosine are opposites of each other, so they cancel. So we have that the inverse of cosine and cosine, since they're inverse operations of each other, they cancel. And all we have left is the theta, which is really what we're looking for. So we have this theta is now equal to, I'm going to put this in a blue box. I'm going to have that theta is equal to cosine inverse of 10 over 13, which is exactly what we have down here. And then from here, so basically we know the ratio. We know the 10 over 13. Our job is to kind of backtrack our way to that angle. So we're going to use inverse cosine to be able to do figure out what the angle is. Now, interesting to note, if you are looking for an angle, so if that's what we're solving for, you are going to use inverse sine, cosine, or tangent. So inverse trig is used to calculate an angle, because we know the side length ratio. We're just trying to back our way up. So if we take a look at question number 1 here, I know the only variable in this problem is theta. Theta represents the angle. I'm going to use inverse trig. But first we have to decide what we've got here. So starting from theta, we're going to identify our sides. So that is opposite. I know that from the box is the hypotenuse. And then the other side right next to theta, that's not the hypotenuse, is the adjacent side. If you take a look at this, we have no numeric values or variables that we're looking for that are the adjacent sides, so we're going to knock that out. We have opposite and hypotenuse. That's going to be sine. So we know that it is sine of the angle, in this case is theta, is equal to the opposite side, which is 14, over the hypotenuse length, which is 20. Okay, we're looking for the angle, so let's look at this trig. If the trig is sine, then the inverse operation of that is sine inverse. So we're going to take this whole thing, and we're going to do sine inverse as the operation, or inverse sine. If we put it on the left-hand side, and then we apply it on the right-hand side. We know on the left-hand side that sine inverse and sine are inverse operations of each other, so they are going to cancel. And then we've got theta. So theta is going to be equal to sine inverse of 14 over 20. Now from here, we grab our calculator. And this is going to be an approximation. So I want to use my sine inverse, which is located on the sine button. And we'll talk about where we can find it in the Desmos scientific calculator as well. So then if we type this in, we will get 44.427. This is an angle, so we're going to put our degrees on there. And then I do want to take a look back at the problem and make sure that this actually makes sense. So if I take a look, it can't be over 90, because remember 90 is the biggest angle. And then if I compare the 14 and the 20, they are somewhat close in size, not exactly, but comparing the opposite and the hypotenuse is going to be pretty difficult to figure out if our angle is reasonable. So if this is 44, I am confident that this is correct because it is definitely smaller than the 90-degree angle that's in the picture. Okay, question number 2. We want to do the exact same thing. Well, if I take a look at question number 2, I want you to take this opportunity, see if you can identify the sides that you're going to be using, and see if you can set up the equation. Then come back and check your equation before solving. So I've identified my sides. I don't have any numeric values on the opposite side, so I'm just going to ignore it. So I'm talking about adjacent and hypotenuse. That ratio is going to be cosine. So I wrote cosine is adjacent x over hypotenuse 25.2. Now, if my trig is cosine, then I'm going to have to use inverse cosine. Oh, actually, do I? No, I don't. If I take a look at this, I'm not looking for an angle. I'm trying to find a side. So I do not have to do inverse. So what I'm going to do here is I'm going to set up my proportions, and I'm going to cross multiply. So this is going to give me 25.2 times cosine of 24. And then I'm going to get 1 times x, which is x. All right, so there's my exact answer. And now at this point, I can just type it into my calculator. So not necessary to use inverse because I'm not looking for an angle. All right, that's going to be 23.021. So I've got my exact and my approximate answer. Do a quick check on this and see if I can determine if this is reasonable. And I think I can, because the hypotenuse is 25.2. I know that any other side length is going to have to be smaller than that. And 23.021 is definitely smaller than 25. Okay, so we've got a couple more examples. Why don't you see if you can set up the appropriate equation for 3, and come back, check your setup, and then we'll solve. Okay, so the ratio that I have is the sine ratio. So I have opposite and hypotenuse. I am looking for an angle this time. So I take a look at the sine. Got to get rid of the sine. To do that, I'm going to do the inverse operation of sine. And then that's going to be applied to each side. So it's kind of our way of dividing by sine, kind of. Or adding sine or subtracting sines, the inverse operation. Okay, here we've got sine and sine inverse right next to each other. We know those cancel each other out, so we'll get rid of that. So it's going to be theta is equal to sine inverse of 3.5 over 8.7. And now we just type it in and see what we get. So inverse sine of 3.5 divided by 8.7. That's going to give us 23.7219. It is an angle, so we'll put our degree symbol on there. And then that's going to be our answer. Now, since we don't know any of the other sides or angles, the only thing I can go off of is just making sure that theta is smaller than 90 degrees, which it is. Why don't you see if you can set up and solve all the way through question number 4. So I identified my sides, and it looks like I have adjacent and hypotenuse, which is going to be the cosine ratio. But I know the angle, so I don't have to do inverse cosine this time. So I set up my proportions and I cross multiplied. Then I went through and I solved and I got 11.32. Since I don't know the other side, the only thing I can compare this against is the hypotenuse, which was 15. And I'm less than 50, it's less than 15, so that's good. All right, let's take a look at the next problem. Now, with regards to this one, you have choices, but it kind of reminds me of one of the past videos that I've done. You don't want to involve both variables at the same time. So my recommendation to you is to just focus on one of them and either solve for A or solve for B first. I am going to solve for A first. So knowing that, why don't you see if you can solve for A, then come back and check your answer and we'll talk about B. Okay, so after solving for angle A, and now I'm going to be solving for angle B. You can do this a couple of different ways. You could do tangent again, but making sure that you identify your sides based off of angle B. Or if we know the size of angle A and we know the 90-degree angle, I think we can just use triangle sum, because we know that the 90-degree angle plus angle A plus angle B has to give us 180 degrees. Now, if we minus the 90 to the other side, we're actually going to get A plus B is equal to 90. But we know what A is, so let's go ahead and plug that in. So 36.8698 plus B is equal to 90. I'm going to subtract that to the other side. You'll get the same answer if you had decided to use trig again, which is totally fine. Multiple ways to do the exact same thing and still be correct. And this is an approximation because we're using our approximate answer here. So if we type that in, it looks like we're going to get 53.1302 degrees. And that covers our notes.